Hello and welcome. My name is Tokebi Games. I am a former Roblox engineer, and I will be teaching you how to develop game mechanics. In my previous videos, we used attributes to define object properties for our dynamic mining system. While that approach worked, it wasn't scalable. Every time we added a new object, we had to redefine all the same properties manually. Today, we're going to take a better approach by moving to configuration files, which are much more scalable and flexible for managing complex systems. To start, create a folder called Configuration Files under Replicated Storage. I'm using replicated storage because sometimes we'll want to access these files from the client as well. If your system doesn't need to share the files with the client, you can place this folder under Server Storage instead. Once the folder is created, add a module script inside it and name it Tools Config. Then, update the module's return variable from module to Tools Config, or any other name you prefer. Next, go into Starter Pack and select one of your tools. We'll start with one of the axes. What we want to do is replicate the tool's attributes inside the configuration file using a dictionary structure. The key difference here is that instead of configuring a single tool, we'll include all the tool tiers in the dictionary. This allows the config file to manage every version of the axe in one place. Once you've moved the data into the config file, delete the original attributes from the tool. Then, add a new tag to the tool that includes its tier and type. These tags will be used by our code to identify the tool and match it with the correct data from the configuration file. Go ahead and apply this setup to the rest of your tools in the starter pack. Instead of using attributes, make sure each tool's data is added to the configuration file under its corresponding type and tier. Once the data is centralized, tag each tool with its type and tier so the system can correctly identify and link it to the config at runtime. This step keeps your tools lightweight and ensures the logic stays in one place, making the entire system easier to manage as it grows. Now let's open the tool script inside ServerScript service and start making some modifications. The first thing we need to do is import our tools config module from the configuration folder we created earlier. Once imported, extract the dictionary containing all the tool data so we can reference it in our logic. This will allow us to dynamically apply properties and behaviors to each tool based on its type and tier using the centralized config file. Once the configuration module is imported, the next step is to update the activated function. We'll start by adding a block of code that prepares the tool for use. First, we get all the tags attached to the tool and set up variables to store the tool type and its configuration data. The first loop checks each tag and looks for a match in the configuration file. Once it finds a matching tool type, it saves that type and stores the corresponding list of properties. The second loop goes through that list to find the entry that matches the tool's tier, which allows us to extract specific values like damage. Finally, two conditional checks assign the correct sound and animation to the tool if those values are defined in the configuration. This setup makes it easy to dynamically apply properties based on the tool's type and tier. Now go ahead and delete the highlighted line from your script. You no longer need it since we're now extracting the correct value directly from the configuration file. Next, remove the line that manually sets the tool's level. Since we're now using the configuration file to handle tool data, we're relying on the tier tag instead. Make sure that any reference to the old level value in your script is replaced with tier to stay consistent with how the config is structured. At this point, you can also delete the line that sets the tool type variable, since we already used the tag to directly access the correct configuration data stored. Next, let's update the add sounds function. Since we're no longer using attributes to store sound data, we need to modify this function to work with the values pulled from the configuration file instead. Lastly, remove the line that previously retrieved the damage value from the tool's attributes. Since we've now switched to pulling damage directly from the configuration file, this line is no longer needed. At the end of these changes, you should have a clean, streamlined script that pulls all its data from the configuration file and no longer relies on attributes or redundant variables. The result is a more scalable and maintainable system that's easier to expand with new tools and tiers. Now let's repeat the same process for your mineable items. Start by creating a new mineable config module script inside the configuration files folder. Then, move the relevant attributes from each mineable object into the configuration file, using the same dictionary structure we used for tools. Make sure to include a loot section in each entry that defines the loot available for different tiers. This will function similarly to how we handled tool tiers earlier. Once your data is moved into the config, go back to each mineable object, delete the original attributes, and add a new tag that identifies what type of object it is, for example, rock or tree. This tag will help the system reference the correct configuration entry during gameplay. By now you know the drill. Go ahead and repeat this process for every mineable item in your game, making sure each one uses the correct tags to identify its type. Once you're done, your configuration file should contain all the necessary data for each mineable object, structured clearly and consistently. This setup will make it much easier to manage loot logic and expand your system in the future. Now let's modify the mineable script. This part will be much quicker, and we're going to do it a little bit differently so I can show you another way to work with the configuration file. First, just like we did with the tools, import the mineable config module at the top of your script. This gives us access to all the centralized data we defined earlier and sets us up to connect each mineable object to its corresponding config entry in a clean and efficient way. Now we have to add a new function to our script called add attributes. This function is responsible for assigning configuration values to all mineable objects in the game. It starts by using collection service getTaggedMineable to loop through every object that has been tagged as mineable. For each item, it grabs its tags and checks if any of them match a key in our mineable list, which comes from the configuration module we imported earlier. Once a match is found, it sets 4 attributes on the object: health, max health, and respawn, all based on the values defined in the config. It also adds a type attribute, which stores the tag used to identify the object's type. The break statement makes sure the loop stops once a valid tag is found, so we don't overwrite values unnecessarily. This setup allows all mineable objects to pull their data dynamically from a single, centralized file, making your system much easier to scale and maintain. After that, delete the line that manually defines raw loot, since we're no longer hard-coding loot data. Instead, update the loot table line to pull directly from the configuration file using the object's type tag. The new line should look like this. This ties everything together by ensuring each mineable object uses its centralized config data for loot logic. With that final change, your mineable script is now fully set up to use the configuration system. Cleaner, more scalable, and much easier to update. Now there you have it. The new system works, and it's cleaner, easier to maintain, and much more scalable. By moving all the data into configuration files and using tags to drive behavior, you've built a flexible setup that's easy to expand and adapt as your game grows. You can have access to this file by following the link in the description to my GitHub repository. Also, please join my community on Roblox, Tokebi Academy, where you can have access to the demos and collaborate with me. If you have not done it yet, please take a minute to subscribe and like this video, as this will greatly help me to continue making this type of content. Thanks for watching, and hope to see your comments and suggestions.